Today we're going to review standards G2 and G5 in 7th grade. They both have to do with triangles and angle measures. Standard G2 is about unique triangles. Something that we just want to start with is just writing some details over here to the side about how to determine if you have a triangle or not. First of all, if you're given 3 sides, you can determine if it's a triangle by adding the 2 shorter sides, and that value should be greater than the longest side. If you're given 3 angle measures, they have to add to exactly 180 degrees. Now we can determine if it's unique in 7th grade by looking for 3 sides that form a triangle, and if that's the case, then we do have a unique triangle because it's not going to change its size because those sides form the size of the triangle. If you're given just 3 angles, it is not a unique triangle because the 3 angles could be the same shape for a very small triangle or a very large triangle. You could have an infinite number. There is such thing as a combination of certain numbers of sides and angles that form unique triangles, but we do not cover that in 7th grade here. Number 7, how many distinct triangles can you draw which have one angle measuring 34 degrees, one measuring 69 degrees, and one measuring 77 degrees? Well, first of all, let's find out, is it a triangle? So let's add 34 plus 69 plus 77, and that does equal 180 degrees. So yes, it is a triangle. However, it could be any size for that shape. So there's an infinite number of distinct triangles that can be drawn with those 3 angles. Number 8, how many distinct triangles can you draw which have one side length of 3 centimeters, one side length of 6 centimeters, and one side length of 7 centimeters? Well, we've got these sides of 3, 6, and 7. So take your 2 shorter sides, add them together, 3 plus 6, and let's see if it's greater than 7. We do get 9. That is true. And since this is a triangle where we know the 3 sides, then it is just one size, which is unique. So there's exactly one triangle that you can draw like this. Standard G5 is about angle diagrams, and these are really focused on finding angle measures and different setups of diagrams. We're going to start with problem number 1. Select the term that tells how each pair of angles is related. So let's start with angles 1 and 7. Notice that this is a special angle diagram. We've got a set of parallel lines. You can tell by these little arrows here that tell you that they are parallel. And we have this transversal line. These 2 angles are on opposite sides of the transversal line. So that makes these alternate exterior angles, and they are congruent to each other. Now looking at the next set of angles, angles 2 and angles 5, notice they're not the same size. Angle 2 is obtuse, angle 5 is acute. In this special diagram, all of the obtuse and acute angles will pair together to be supplementary. And so these will be supplementary. But you can tell because this is acute and obtuse, I could move this angle 5 here over here to angle 1 because they correspond to each other. And then I get this set of 2 angles that add up to 180 degrees. So that's one way I can kind of prove that. Okay, our next set of angles, angles 4 and angle 6, notice they're both obtuse angles, so they're going to be congruent to each other. I can also tell that they are congruent because I know they have a special angle relationship. They are on alternate sides of this transversal line, and they are inside the parallel line, so they are alternate interior angles. Last, we have angles 3 and 8. 3 is acute, 8 is obtuse. They would just be supplementary to each other. I do want to address a couple more things. If you have an angle such as 1 and 5, they are made up of the same angle of 2 different intersections. They are called corresponding angles. and they are equal or congruent to each other. You could also look at an intersection, such as this intersection here, and see that these angles that are on opposite sides where two lines cross, such as angles 1 and 3 here, that they are equal to each other. They are called vertical angles, and they are equal or congruent to each other. Number 2, if the measure of angle DAC is x and the measure of angle CAB is 2x minus 30, what is the value of x? Well, notice that these two angles add up to 90 degrees here. Notice that DAC, we can just look here and say, well, D to A to C is this angle, and it is x. And then we have CAB, we can just measure C to A to B, and that is 2x minus 30. And together they add up to 90 degrees. So I can say x plus 2x minus 30 equal 90 degrees. I could solve this for x. X plus 2x is 3x. Bring everything else down. We have a two-step equation. We'll add 30 to both sides. We get 3x equal 120. Then divide both sides by 3, and x is 40. And we're looking for the value of x, so we're done there. Sometimes it goes beyond that and asks you to plug that back in and find an angle measure, but this just found x. Number 4, describe how angles A and B shown below are related. Well, they're on opposite sides of a transversal line and outside these parallel lines, so they are alternate exterior angles, and they're congruent to each other.